As we turn the paper over to page 12, we can use this same idea. We use the angle addition on page 11. Now we're going to use segment addition. The key here is draw a picture. The pictures really make a big difference when we're dealing with these. And what it says is, it says point F is on line segment EG. So here's E, remember it's a segment, EG, and point F is somewhere on there. I tend to draw point F on the middle or close to it. It does not have to be in the middle. In fact, as I look at this segment that I just drew on screen, it doesn't look like it's quite in the middle. But then label what we know. It says EF is 6, and EG, this entire length, is 11, and we want to figure out, well, what is this length here? So what we can do, again, we can call this X if we use some algebra to it. You can use some common sense as well. But 6 plus X, if we add those two parts, those two segments, they add up to be the entire segment of 11. And if we subtract 6 from both sides, then we're going to get X, which, by the way, is really segment FG, which is 5. 11 minus 6. Again, draw the picture. That's going to make the difference here. Example 2. Point R is on line segment QS. So we'll start with our line segment QS. And then point R is on there. It doesn't matter where we draw it. We just need a segment R in there, and I'm trying not to draw them in the middle, although I tend to draw them in the middle. It says given that QR is 4, so definitely my picture is not drawn to scale, because RS is 7, and what we want to find is we want to find the entire length of this segment. So all that we have to do is take the 4 plus the 7 equals 11, and that's going to be the length of our entire segment of QS. Maybe I'll do better on number 3, example number 3, with our segment. Point S is on line segment RT. Draw the picture. All geometry teachers are probably really insistent that you draw the picture. So here's RT. Point S is on there, so somewhere here. Point S is on line segment RT. Given that RS is 2 and RT, the entire length of our given statement, is 13, we want to determine the length of ST. Again, I'll call it X and apply some algebra to it. You can use common sense. You don't necessarily have to use the algebra, but 2 plus X, there's the segment addition, equals 13. And we'll subtract 2 from both sides. That gives us X equals 11, which is really the fact that we're looking for segment ST equals 11. And lastly, point C is on line segment BD. Here's our segment BD. And then point C is on there. And I tried to draw it a little bit more to scale, but it says CD has a length of 2, and BC has a length of 8, and we want to know the length of the entire segment. So we're going to take the 8 plus the 2 to get 10, which is our length of our entire segment BD.